the Technology for Property Rights project is back with the third season of Do's and Drones. For this one, we're going to do a series of lectures, so it's going to be longer than the first two seasons that we've had. So just a quick recap. Season 1 touched on the ABCs of drone surveys. And then Season 2, it featured various drone applications apart from surveying and titling. And for this season, we're going back to the basics. So that is to know and understand how drones fit or unmanned aerial systems fit in the field of surveying. By knowing this, current and future drone users would be able to optimize the technology. To kick off the season, we've invited again a big personality in the field of geodetic engineering. To introduce our speaker, let me call Engineer Rhea Lindialca, the Director for Projects Administration of the Foundation for Economic Freedom. Ms. Rhea, the spotlight is yours.
Okay. Yeah. Magandang umaga po ulit sa ating lahat. We welcome you to another episode of Do's and Drones. And it is an honor for me to be giving this introduction to our speaker for today. So I'll start now. He is a known and well-respected personality and is also one of the most sought-after resource speakers in the field of geodetic engineering in the Philippines. Almost every GE student and practitioner knows this person. He started as a commissioned officer of the Bureau of Coast and Geodetic Survey at the Department of National Defense in the 1970s. He became the chairman of the UP Geodetic Engineering Department and UP Training Center for Applied Geodesy and Photogrammetry from 1994 to 2004. He was also the chairman of the Technical Committee for Geodetic Engineering of the Commission on Higher Education from 2003 to 2014 and is now a member of the same body since 2015. Currently, he is the chairman of the Professional Regulatory Board of Geodetic Engineering. He acquired a master's degree in engineering science from the University of New South Wales, Sydney, Australia, a postgraduate diploma in photogrammetric engineering from the International Institute for Aerospace Surveys and Earth Sciences at Enschede, the Netherlands, and a bachelor's degree in geodetic engineering from the University of the Philippines in Diliman. So ladies and gentlemen, without much further ado, please join me in welcoming Professor Epifanio Lopez. So take it away, Prof. Ping. You may now share your screen.
Thank you. This has to do with unmanned aerial systems, a quantum leap. I say a quantum leap because if you remember our physics, the electrons jump from one energy level to another, assuming that the next energy level is a higher one. So our topic this morning will discuss the technology trends, then the quantum leaps in surveying, the structure from motion photogrammetry, or some call it UAV photogrammetry, and then the mapping accuracy and error sources, and then some concluding words. So very brief lang ito. So the overarching technology trends include the miniaturization of technologies. If you recall, in photogrammetry, we used to have aircraft. Now we are using drones. And of course, the proliferation of new platforms, basically drones. Then we recall the speed of computers using transistors. During our time, we were using computers as big as rooms with very small memories. But now you can count on gigabytes, terabytes, and in the next few years, zettabytes. So for our quantum leaps in surveying, these were caused by disruptive technologies. And disruptive technologies actually displace the existing technologies, and it shakes up the industry. So these are the quantum leaps in land surveying. driven by disruptive technologies. If we recall the rope stretchers from Egypt, all the way to the invert tape. I am not sure if most of you still remember the invert tape, but I can see that most of those attending are millennials. Baka retrato na lang nakikita nyo with the invert tapes. You may not even be familiar with the theodolite anymore, or even the transit.
Hi, Prof. Ping. Mukhang na ano po, I'll unmute you. Sandali lang. Please unmute na lang, sir. Ayun.
Ano wala?
Ako, na-mute niyo, sir.
Nga, okay na?
Okay na po, okay na.
Okay na?
Yes, sir.
So the first quantum leap has to do with the EDM. Instead of using the tape, the electronic distance meter actually was a big improvement in surveying. And ayaw mag-move. Yeah. The first model was the MRA-1 in 1957. This is South African equipment. And the model that we were using at the Coast and Geodetic Survey was the MRA-3. It had a range of 70 kilometers, and we were using this for long-range traversing in Mindanao and Palawan and the other parts of the country. It was followed by the Swedish geodimeter, and it had a range of 30 kilometers using light. Then in the late 60s to the early 70s, the total stations came into the picture. This is now the next leap. This is the Zeiss. This is an East German total station. And of course, we had the robotics in 2004. But the robotic stations did not seem to be popular because of the cost. It was quite expensive. As far as I know, maybe there were 2 users who bought these robotic total stations. And then the next quantum leap was the GPS, which now most of you should be familiar with. The first few satellites were launched by the US in 1978, but the complete set of about 11 or 12 satellites was completed in 1985. And this brought us to our real-time kinematics surveying, utilizing the GPS, as well as other GNSS satellites. Then the leap number 4 came in mid-2000 with the laser scanning or LiDAR and the terrestrial laser scanner. So this supplemented actually the aerial photography component of surveying. So instead of buying aircraft camera, metric camera, the laser LiDAR was being used. Then the leap number 5, which we will discuss in more detail, has to do with the drones. About 2010, the microcopters or the quadcopters and the fixed wing EB came into the picture. And a few years back, the Swiss Wingtra and the US Firefly also came into the picture. These are now the common drones used in UAV photogrammetry. I think the structure from motion photogrammetry is actually the technology that drove the use of UAVs for surveying and mapping and other applications as well. Photogrammetry is an old remote sensing technology, but there was a significant development with the introduction of the computer vision algorithm known as the scale invariant feature transform. So this is the heart of the SFM photogrammetry, the SIFT algorithm developed in 1999, presented in 1999, refined in 2004. Together with the SIFT is known as the workflow or the multi-view stereopsis workflow. Stereopsis is similar to our traditional photogrammetry technology of stereoscopy, where you can see 3D from two-dimensional photographs. So let's go back briefly to the development of photogrammetry from the 1850s all the way to the invention of the aircraft in the 1900s, and the analytical photogrammetry, and now the digital photogrammetry. The current market actually has to do more with the digital photogrammetry. So the traditional photogrammetric mapping dealt with single exposures or sequential exposures with square frame, and with overlaps forward, overlaps of 60% standard and 30% side lap. But with structure from motion, the features are no longer dependent on fixed overlap and fixed side lap, but rather on the motion of the camera, which actually matches the features or makes correspondence of the features on the ground. So the motion is provided by the camera aboard the drone, and the features represent these structures. The basic trigonometry or geometry of photogrammetry has to do with common points in photographs. So this is a range imaging technique. This is similar to our resection technique in or intersection technique in surveying. So if you have 3 points or 3 features, then you can identify the common features or common points from the 3 photographs. So the structure from motion actually reconstructs the geometry and then the camera positions. And the features, as they increase in number, become the cloud of points, which is developed by the image processing software. So these are examples from Pix 4D for cloud points, which I'm sure you're familiar with by now. And in traditional photogrammetry, we have to make use of vertical photographs. There is a limit to the tip and tilt of the photographs. You cannot exceed plus minus 3 degrees from the horizontal. Otherwise, we request the contractor to refly, because photographs that exceed 3 degrees from the horizontal are rejected. Unlike in structure from motion, this is different. You can fly from any orientation, any angle, provided there are common features. These photographs are accepted by the SFM software. SFM deals with, you can process varying scales, you can view from different angles, you can view from different orientations. This is not possible in traditional photogrammetry, because in traditional photogrammetry, you have to identify the projection center or perspective center for each photograph, or the exposure stations for each photograph. And this should be vertical or near vertical photographs. This is a big difference, the viewing angles and the orientation of the images. So the general flow of UAS mapping normally follows the same traditional photogrammetric procedures, but here we can have a shorter workflow. It includes a quality control stage. The multi-view stereopsis workflow as provided by Walter Volkmann is presented in this slide. And this was actually developed also by Westoby in 2012. So the two key figures in SFM photogrammetry are Lowe, who developed the SIFT algorithm, and Westoby, who further refined the MVS workflow. And Walter Volkmann says that the SIFT algorithm starts with the generation of the point clouds from the sparse point clouds up to the dense point clouds. And the workflow includes the post-processing steps. Just to give you an idea of the SIFT, I think we will be entertaining some questions. As I think, Angela, we need to entertain some questions here, or?
Sir, yes, we'll entertain some questions.
Yeah, I forgot
right
about
now.
after the lips. We should have entertained questions. Yes.
It's okay, sir. It's okay, sir. No worries po. So, guys, if you have questions to, okay, someone raised his hand. So, Raymond Katache, so can you please, yes, you can unmute yourself. Raymond Katache. Hello? Okay. Mukhang,
Pindot
hello?
lang.
Mukhang baka napindot lang. Okay, so if you have questions, guys, for Prof. Ping, until this part of his presentation. And okay, sir, mukhang wala munang may questions for now.
So shall
okay po, you can resume.
Shall I proceed then?
Yes, sir.
Okay. I'll continue with the scale invariant feature transform. And as I was saying earlier, this comprises the heart of the SFM software. And this is a computer vision algorithm. So the SFM photogrammetry or UAV photogrammetry is actually a combination of photogrammetry in partnership with computer vision to develop this technology. This is patented by the University of British Columbia and published by David Law in 1999, refined in 2004. This is a very popular algorithm. There are many applications, but for us, in the field of surveying, mapping, and monitoring, we find application in object recognition, image stitching, and 3D modeling. These are the three primary applications for us here. So as you can see the next slide here, with SIFT, you can actually correspond, you can match features even if they have varying scales. In traditional photogrammetry, you cannot do this if the scales differ by about 10 to 15%. Adjoining photographs, you can no longer match them stereoscopically. And you can have different viewpoints. You can have partial shadows. This is not possible in traditional photogrammetry. And you can have changing illumination. So these are advantages for the SIFT algorithm. Why is SIFT popular in so many disciplines? The basic advantage is object matching or correspondence of points on the ground. As you can see here, all points, whether viewed from different angles or different orientations, can be matched by the algorithm. And in the slide here, you can see the features matched and they merge into one image. The next topic has to do with ground sampling distances. The smaller the value of the GSD, the clearer is the picture. So as you can see here, a 1.8 cm pixel gives you a clear picture of the cars as compared to the almost blurred image for the 15 cm per pixel image here. So the GSD is the distance between the center points of two adjoining pixels. And this is an example of a 20 megapixel camera as compared to a higher number, 42 pixel camera. You can see that there are more features that can be seen in the 42 megapixel camera. For illustration, this is a feature of two cameras. We're using the same GSD, but different megapixels, different altitudes. This is 20 megapixel camera. The coverage is 64 hectares, flying at 57 meters. And this is a different camera. Same GSD, but different coverage, higher coverage, and higher altitude. This gives you advantage or disadvantage, depends on what drone and what camera you have. I don't know if you have some questions up to now. We can entertain some questions before we go into the next more serious topic.
Okay, guys, you heard Prof. Ping. Do you have any questions? If you have, please raise your hand or chat or write your question here sa ating chat box. Okay. Sir, mukhang ano sila ngayon, mukhang hindi ko alam kung na-overwhelm, nahihiya, or they fully understood what you presented and they don't have any questions.
Yes, thank you for not asking questions.
Okay. Sir, mag-shoutout lang po ako sa mga nag-message sa chat box po
Oh, okay, yes.
Sige po. Hello po, Engineer June Almero of Mambura Occidental Mindoro. Also, good morning from Engineer Antonio T. Aninion from Muntinlupa City. Ayun, sila yung recently na nag-shout out. So, sir, mukhang walang questions. You may proceed.
Just tell me if it's too fast, or if it's too slow.
Okay po, sir.
As I said, I have two clocks here, one fast and one slow. I can use either.
Okay po. Oh, good morning, Pahabol. Good morning from Mandaue City, from Josie Ann Mayol. Okay, sir, the spotlight is yours.
Okay, thank you, Angela. We now go into the mapping accuracy of UAS. This should concern all users, whether you are a geodetic engineer or civil engineer or architect, because the output, as you know, in our profession or the other professions, we are concerned with the clients, the accuracy for the safety of the public. So we have to be concerned with this topic. So the GCP accuracy is covered here, the spatial resolution, and the camera calibration accuracy. The accuracy is normally expressed as a root mean square error. And we can show you the effect of the number of GCPs on the RMSE. In traditional photogrammetry, the accuracy is expressed in lines per millimeter. So you can see the fineness or the precision of the measurements. Here we express the measurements in root mean square errors. So these are totally different measures of accuracy. The basic method for measuring the root mean square error accuracy in UAV photogrammetry is the use of checkpoints. Checkpoints are established together with the establishment of the GCPs. The GCPs are used to orient the project, to rectify the image. But the checkpoints are used as independent check for the accuracy of the output. This is the important thing. So if you're using outputs from UAV photogrammetry, make sure that in the narrative report submitted by the contractor includes how the accuracy was obtained. This is an example of a project area in the University of Florida. And note here that the contractor or the researchers, investigators actually used only 4 traverse stations using robotic total stations, but they established 23 checkpoints. And the checkpoints were established on the ground, the yellow ones. The blue test points came from a terrestrial laser scanner used together during the project, together with the other stations and the other equipment during the project. And you will note here the test points came from the laser scanner. So this came from the tops of buildings, edges of buildings as visible on the imagery. And root mean square error achieved was a very low 2 centimeters, approximately 2 cm only. In the example given by Walter Volkmann, who was in the Philippines a few years back, he tested the use of drone photogrammetry with and without GCPs in Bacoor. So the accuracy comparison is at 95% confidence level. The 95% confidence level is an internationally accepted confidence level, but there is actually a limitation. You need at least 20 checkpoints, at least 20, to avail of the 95% confidence level to be at international standard. But anyway, in local researches, we have been using less than 20. So it may not be the 95% confidence level. Here, Walter Volkmann used 22 GCPs for the controlled mapping, and another one with 27 model points without GCPs using PPK. And the accuracies are very high, still 0.07 7 cm and 7 cm. And the root mean square errors are at the levels of 4 cm and 4, but the horizontal accuracies has to be multiplied by, you have to multiply the root mean square error by 1.7308. For those not familiar with this constant, this was developed during our time, or during, not exactly during our time, a few years before our time, in least squares. So if you're familiar with least squares, this is a constant used to multiply, and this is accepted by the US Federal Geodetic Committee and the American Society, and this is an internationally accepted constant. So this was the drone used by Walter Volkmann in Bacoor in 2017, together with the attached GPS PPK receivers. And this is another case study in England where 10 GCPs were used by Barry and Copley, but he established 45 checkpoints. And note the accuracies, which is 4 cm for the XY, although 2 to 3 times for the Z. This means that UAV photogrammetry can actually meet the manual for land survey limit of 10 cm positional accuracy. If you remember the provision in our manual for land surveys, we have the positional accuracy of 10 cm. That if you convert that to root mean square error, you need about 4 cm on the ground to attain it, the limit of 10 cm. The effect of GCPs on root mean square error. There is an accepted number of GCPs, about 5 to 10 GCPs would be sufficient. If you increase the number of GCPs, it has no big effect or significant effect, and the root mean square error. This is tested again in another area in a quarry in the US. As you can see here, the GCPs include 21 with only 11 checkpoints. And the number of the RMSE is actually constant beyond about 4 to 10 GCPs. So does it mean that more GCPs can have more accurate drone maps? Well, based on these slides, parang hindi. 4 to 10 would be sufficient. There is a reservation lang dito. If you are using different software, the accuracy you obtain may be different, particularly for the height measurement. For the XY measurement, maybe this will be negligible. But if you are using digital elevation models for your outputs or DSM models, using different softwares will give you different results, as the height component is most sensitive to this RMSE. So that will bring us to our next topic, unless you have any questions. Unless Angela has any question.
Okay. Let's entertain some questions, guys. If you have questions, again, kindly put them in the chat box or raise your hand. If wala, I'll just read the shout-outs here in the chat box.
Yes,
So,
okay.
good morning po sa lahat from Engineer Melvin Candelario. Shout out to Geodetic Engineering Society of the University of Southern Philippines Foundation. USPF was our partner last year in rolling out the standard training module in the Visayas. In the Visayas. Good morning sa lahat from Charlie Manait and Marvin Caranzo. Oh, he's saying na shout out ko po sina Engineer Miriam Santillan and Georgine Santillan, one of the best instructors of Caraga State University. From one of your products, Engineer Marvin Caranzo. So CSU was also our partner last year when we rolled out the training module in Mindanao. Prof Ping, mukhang walang may tanong. Hindi natin alam kung na-overwhelm sila or they fully understand what you've been saying.
Two things lang yun, di ba?
Opo.
Either they do or they don't.
Yeah.
But anyway,
Sige po.
malaman nito this is actually a topic that's not included in our curriculum offered in CHED. So this is something new actually. And most of the initial users of this were actually from other disciplines. We cannot avoid that. So this is something new. Even in the Dr. Blanco admits this has to be included in the revision of the curriculum. Yes.
Okay.
And this is not yet included also in the licensure exams kasi wala pa ito sa curriculum.
Okay. But it's good po that we have a venue like this na at least people would have an idea or their knowledge on this would be widened or broadened. So,
yeah, actually, if we can present this to the different HEIs schools, I think this will be helpful, particularly with the costs going down for many of these drones. I think this can be very helpful.
Okay po.
So shall I proceed with the next slide?
Sir, can we have a quick 10-minute break?
Yes.
10-minute break. Yeah. Just so we can have a class photo.
Okay.
Sige po. May I sir, pa-stop ko muna po ang inyong screen sharing.
So how do I stop
ako na
share?
lang, sir.
Ikaw na lang.
Yes, sir. Sorry. Hindi ko siya ma-stop pala, sir. Can you please stop it from your
Ako na
end?
lang.
Yes, sir.
Stop share screen.
Ayun. So, may I request all of the participants to please kindly turn on your camera because we're going to have a class photo. We have 99 participants now. Just want to see everyone.
Actually, this is
Cesar?
100 already.
Yeah.
100.
Oh, yeah, we're nasa 100. So, guys, smile. Hindi ko
Cesar.
alam kung anong panel eh. But yeah, please smile na lang. This will be quick. Okay. 1, 2, 3, smile.
One, two. Sapa. Okay, the third one. 1, 2. Smile. Ayan si...
Okay na po, ma'am.
Okay. Thank you. Okay, guys. Let's have a short game before we continue kasi medyo heavy yung ano, I think the next slides would be a bit heavy compared to the previous one. So let's have a short game. It's very simple. If you want to answer, you can unmute yourself, okay? Okay, I'm gonna share screen. I think you've seen this already circulating in Facebook. Ayan, hope you can see it. So according to the one, this is a game. This is a short game. Sabi dito, there are 40 Beatles songs that can be found in this picture. So if you want to answer kung anong song yung nakikita nyo na Beatles song sa picture na ito, please just type in your answer or you can ano. Ayun, may sumagot, Yellow Submarine. So we have one. Anything else? I have the answers here. Here comes the sun, okay?
Hi, Sir G.
Ano pa, guys? I mean, this is, I think, Beatles has been around for a few decades. So, here, there, and everywhere. Okay. So, the millennials, I think, alam din natin to. Hey Jude, okay? That's one. 8 days a week.
Hello kay Crucel Ocho. Kay
Yesterday.
Acto.
Yesterday.
Tayo na yung shout.
Blackbird, okay. Octopus Garden. Shout.
Paano kaya yung yesterday?
Saan kaya yung yesterday? Saan kaya nakita yon?
Paano kaya nangyari yung yesterday?
Yung may sun?
Oh, pwede ba yun? Oh my God, merong Maxwell Silver Hammer.
Strawberry Fields Forever, okay. Penny Lane. I Am the Walrus, okay. I Have One, Her Majesty.
Get
Get
back.
Back.
Get back.
Mm-hmm.
Si Larry Alcala. Kita niya.
Get Back, okay. Wala siya sa Facebook, pero merong Get Back. Anything, Dr. Robert? Dr. Robert. Okay. Dr. Ticket to Ride?
Ayan, may ticket booth.
Okay. Ano pa, guys?
Paperback writer. Aba?
While My Guitar Gently Weeps, okay. Guitar Man.
While My Guitar Gently Weeps. My gosh, di ko alam
Okay.
yan.
Taxman.
Ayun
Strawberry
sa
Fields.
natin.
Lucy in the Sky with Diamonds, okay.
Diamonds. Kung makita.
Okay. Back in the USSR.
Strawberry Fields. Asan yun? Ayun. Ako.
Strawberry Fields, asan kaya? Pass the message, okay. The Foot on the Hill. Strawberry Fields. Ah, there. Strawberry Fields in the upper right.
Dig It. Joel, hi. Merong ganon? Dig It?
Dig It, yes. Merong Dig It. The Long and Winding Road. I was about to say that. The Long and Winding Road, okay.
Sa gitna. Upper.
Sige, last two, and then we'll proceed with, I will resume with Prof. Ring's presentation.
Help!
Help.
Help. Ayun, nalulunod.
Yep, help. Drive my car, the doctor. Okay, character game. Ang dami ah. Wala dito sa list ko. I guess mas marami nga. It's more than 39.
Yeah.
Eleanor Rigsby. Okay.
Lenore.
Okay, guys. People society, fixing a hole. So I think marami pa tayong may kita dito. I hope you guys enjoy this short game. And then now we'll resume. I'll stop sharing.
How many songs ba, Angie?
Sabi po dito, 40.
Wow, may people in the society pa. Hindi ko alam
Ayun.
yun.
Prof.
Right.
Ping, you may now share your screen again. We'll get back to you.
Okay, yes.
I bet Prof. Ping marami ka rin nakita doon sa doon sa picture.
Hindi ko inaabot yun eh.
Hindi nyo na naabot yun.
Ang nakita ko lang yung sagot ni Attorney Clemeno. Hi, Attorney. Pero ang sagot niya yun yata yung cartoonist eh.
Sige po, sir.
The next topic has to do with the sources of errors. As in any discipline, there are sources of errors. And this field is no exception. So the first source is the lens. The lens, if there is any distortion in the lens. In traditional photogrammetry, the cameras are sent to the factory every year. So they have to check the lens distortion if there is any, and they apply additional lens distortion correction. So that's very expensive. In UAV photogrammetry, the lens distortion is different because we are using consumer grade cameras, and the lens distortion is quite easy to check actually, but sometimes we don't discuss this. And then the doming effect. Doming has to do with the parallel lines in UAV photogrammetry. Then I added this rolling shutter. Rolling shutter is not part of the slide shown by Angela. Rolling shutter has to do with the type of shutter in the camera and the image blur. These are potential sources of errors. So the lens distortion can result in these images. As you can see, it can be a pincushion image. It can be a barrel distortion. Depends on the lenses that you have. But these are self-calibrated during the image processing. So for most software in UAV photogrammetry, these are corrected anyway, but these should be checked from time to time. The other source of error is the systematic error caused by the near parallel flight line. So for the XY component, this may be negligible. The errors caused may be negligible, but the height could be sensitive. So we have to correct the dome. This is called the doming effect. And there are corrections that can be done. If this were the image that you can see, the left image is the no dome image. The right image will be shown as far as with the reddish tint. This is a doming effect. And the possible corrections is to fly oblique angles so that the flights can be corrected. In traditional surveying, this is done as well. In hydrography, this is done. In traditional photogrammetry, this is done. So UAV photogrammetry should also include this. Flights with oblique flight lines. As far as the camera parameters are concerned, you need to photograph a calibration target from time to time to check whether the lens distortion is still negligible or not. This is another source of error, the shutter. As you can see, there are two types of shutter used in UAV photogrammetry. The global or total shutter exposes all of the pixels at the same time. There's no error in that. It uses CCD sensors. It's more expensive than the rolling shutter. The rolling shutter exposes each pixel at a different time. So this can be a source of error. It can cause, initially, the first sign is the image blur. Sometimes the blur may be caused by the focusing of the camera, but it can be caused by the rolling shutter. This is popular because it's one of the factors why the camera for this is very cheap. So it would be worthwhile if the drone can have interchangeable cameras. You can have the rolling shutter camera or the global shutter camera, which is definitely more expensive. This is the problem with the rolling shutter. The distance between the first and last pixel lines can be up to 1 meter. At the average mapping flight speed of about 8 meters per second, flying about 50, 60, or 70 meters above ground, you can have a 1 meter difference. And this can cause problems in feature matching. So if you have inaccurate camera parameters, you will result in poor accuracy. But there's now a solution to this 4D 2.1 version. There's now an algorithm. So it treats the individual pixels individually, the pixel lines as they have their own orientation. So if you're using Pix4D, maybe this 2.1 version should correct this. The image blur is another feature where it may contribute to the prevention of the automatic process. Because if you cannot identify your GCP, if you cannot identify the feature, then this will, of course, prevent the automatic process from working. But there are now algorithms introduced by software. They can use overlapping images to sharpen the blurred image, or there is an algorithm called an edge shifting deblurring algorithm. Well, of course, the easiest method without using algorithms is simply to remove the blurred images from the set. So unless you have any other questions, if you have no questions, I can proceed with the last part. Angela?
Sir, mukhang walang nag-raise ng hand or nag-input ng question sa chat box. I think you may proceed, sir. Yes.
So I will now proceed. As you can see with drones, the future for not only land surveying but other disciplines is exciting. As you can see, there's a lot of opportunities here. Let's look at this. Well, initially, I look at land surveying, and in the last several years, particularly from 2011, if you look at this slide, there has been a lot of publications involving environmental, agricultural, but almost all fields in the sciences, even in the social sciences. In 2017, only about 200 publications, but last year, this rose to 605. So you can just imagine the number of users, no, or potential users. Hindi pa kasama dyan yung mga nanonood ngayon, no, saan nakasama natin. So this will exceed 600. So a basic application would be in land surveying is using this as backdrop for our land surveys, property surveys, or if you use the circular of the Land Management Bureau, this can be used for the generation of technical descriptions subject to field validation and approval by the concerned land management services, regional offices. This is now being used in many countries for mapping for property surveys. A possible application is the 3D cadastry. As you very well know, the 2D cadastry is, as they say, is complete or is finished, although not completed. And the LNB is embarking on a 3D cadastry. The UAVs will be useful for this. In fact, I think the LMB already has acquired some drones for projects in 3D cadastry. And in the US now, some practitioners are using drones and UAVs, UAV photogrammetry for 3D property boundaries, especially if the boundaries cannot be seen, if these are not visible, they can present this to the owners. Of course, the general output of orthophoto maps, this general practice, even for the presentation of proposed subdivisions. I know our colleagues engaged in real estate services are using drones for presenting such outputs for their clients. And of course, the traditional urban mapping. As you can see, the images are quite clear. Of course, high resolution satellite imagery can be used, but this can be a bit expensive also. Then different elevation models, terrain, elevation, or surface models, depending on the requirement of the clients. And then volume measurements in mining areas. The traditional method is to use RTK, perhaps, or total station and rods. But the drone will give you a more accurate surface area and contributes to a higher computation of the volume. And then in the build projects of the DPWH, the engineering consultants are looking for drone specialists, because I know some consultants have acquired their own drones and are using this to generate outputs for preliminary engineering design analysis, corridor assessments, right-of-way realignment and widening, and even bridge site surveys. These are civil engineers, architects who are in multidisciplinary consulting firms of the DPWH. If you can get in touch with them, they are using drones now for these projects. Of course, we can use this for nearshore coastal mapping. LiDAR used for nearshore can go to depths of about 10 meters for clear water. And then river mapping, of course, is another application. We had an application last time from the NCR. I think they were mapping the informal settlers along the rivers. Of course, that's a more difficult task because the right-of-way has to be delineated along the informal settler areas. In Malaysia, our colleagues, through their JUPEM, the JUPEM is their national mapping agency, equivalent of NAMRIA, they're using UAS to update their outdated orthophotos and contour maps. At NAMRIA, I think they're using high resolution imagery, but I know they have bought some high-end drones. I don't know how extensive these are being used, if they're being used for revision. And the last few slides, there are emerging innovations in drone photogrammetry, in underwater hydrography, and in construction staking. You might be surprised. UAV in Israel, this actually originated in Israel and now used in some parts of the US. So let me just go through this. The Rutgers University Laboratory has developed a platform that can go to 200 meters deep in the waters, clear waters, for hydrography. This is not commercialized yet, but it is there. Maybe they're waiting for some investors before they can have this on a commercial basis. So this is possible. And finally, the construction staking UAV. A few years back, we were joking about, I think in an assembly of the GEP at the in Ermita, we were talking about drones carrying mohon, But this one uses stakes. Two Israeli engineer surveyors were engaged by a construction firm, and they developed a drone that could carry about 40 to 60 stakes. And they were able to test this in construction areas for site layout. And this uses a dual antenna RTK and inertial monitoring unit for orientation. And it is able to land within 5 cm secure, accuracy. And there is a footprint within the 5 cm accuracy is within the 20 cm by 20 cm square footprint before the stake is finally marked on the ground. The UAV uses a drill to insert each stake in the ground, and depending on the length of the project, it can carry 40 to 60 pieces. It has a payload of 9 km. I look to the day when a Filipino geodetic engineer or other inventor can invent a Mohon carrying drone, and you can be granted a level 8 category, PhD category by the Free Professional Regulation Commission, I guess. In closing, I would like to say that the use of drones is not confined to survey and mapping. There are various applications, various disciplines. So the drone with the RTK can be considered a tool like the GIS because it is used in many, many disciplines. As I said, the heart of SSM photogrammetry, the SIFT SIFT algorithm was not developed particularly for surveying, but for other applications. So UAS is an opportunity waiting for us, not only for surveyors, but all other disciplines. So thank you very much for your attention. And thank you also for not asking any questions. Angela?
Thank you, Prof. Ping. Actually, sir, may mga marami-rami na pong tanong dito.
But di ba hanggang 11 o'clock lang?
Ay! Sige po. Sir, you may now stop sharing your screen.
Yes, okay.
Okay po.
Ayan, yan na yung inaantay natin next time. Pwede nang mangisda using a drone.
Ayun.
Okay na?
Okay po. So guys, ito sir, Prof. P, meron pong tanong dito si Ma'am Joanna Taganahan. Sabi niya po, Sir, it is recommended ba na pwede gamitin ang drone for detailed engineering design? She's a GE from DPWH Caraga.
Actually, for DED, Detailed Engineering Design, you have the pre-feasibility, you have the feasibility, and then the detailed engineering. For pre-feasibility and feasibility, no problem. You can use that because the accuracy can exceed more than the limits set by the manual for land surveys. But for the detailed engineering, it depends. If you are using high-end drone with high-end software, I think you can use it because the accuracy attained actually meets accuracies for detailed engineering of a few centimeters. Otherwise, if you are using, well, not so high-end set, I suggest you can still use this, but validate with ground measurements, random. This will not replace the ground component in DED. It will supplement. But for most designers for DPWH, they use the drones for pre-feasibility and feasibility now, unless the terrain is not accessible by both the surveyor and the engineer. Then I think they use the high-end drones. It depends on the limits set by the consultant. But yes, it can be used, yes.
Okay. Thank you, sir, for that question. And thank you, Ma'am Joanna, for that question. And Sir Prof. Ping for the answer. Another question po. In the near future, from Wilbur Cadiz, in the near future, is there a possibility that recreational drone can be used in surveying with the help of surveying apps? Recreational drone, those sir, can be used in surveying with the help of surveying apps.
Recreational drones.
Yes, sir.
Recreation is yung ginagamit sa mga weddings and
Weddings.
hobbies ba?
Sabi,
I
yes.
think the accuracy there may be doubtful for applications in land surveying. For land surveying, actually, I think the rule should be such that the drone should be able to meet the manual for land survey
Yes.
provision. And the second condition is that it is submitted to the appropriate government agency for approval for titling purposes. If it's not used for titling purposes, the user may use a recreational drone for whatever purpose he deems it proper for her or for him.
Okay. Thank you, Prof. Ping. I think clear naman na yung drone na ating gagamitin should be survey grade, if I'm correct. Also, sir, yes, please.
Should be
Yes, survey grade. If your application, actually the use should depend on what output you want to generate.
Okay.
If you want to generate outputs for the DNR or LRA, or for maybe for high precision outputs for NAMRIA, this should be survey grade. Otherwise, pwede naman hindi.
Thank you, sir. Sir, may isa pong question dito. I think this is it concerns the field of civil engineers. So from Maria Cruzet Kiocho, is it accepted by CEs and users, yung drones daw po? If you know if it's accepted by CEs, and up to what level of study is it applicable? And what are the general site condition the method will be applicable, sir?
I think she's referring, sir, dun sa staking, yung drone staking, yung nag-i-stake na drone.
I staking. That was tested in Israel. It was tested by the in a state in, I think it was in Iowa, for their road staking. You know, their accuracies for road staking is not as accurate as what we have here anyway. So, inaccept nila yon. But for us here, in civil engineering, the application is more on, as I said, for DPWH's consultancy projects, more on the pre-feasibility and feasibility, even without ground validation. But if it's used for detailed DED, detailed engineering, sa ngayon, to be safe, if I were the GE, I would supplement this with ground surveys, kahit random man lang.
Checking. Yeah.
Random checking. Thank you, sir. May ano po dito may question din po related to that. If kailangan pa daw ng mag-establish ng GCPs if you're using drones with an onboard RTK.
Depende. What's the accuracy required by the user? Is it only for presentation to the owner, just to determine the area? No problem with that. If you just want to determine the area, but if you want to delineate the boundaries and place monuments for approval, with survey plans for approval, then yes, you need GCPs. Yes.
Okay. Another question, sir. Some parrot drones have fish lens mounted for a more wider view. Is there a way the images could be corrected and to generate higher accuracies? Are you ito sir from Joel Marundan.
Paano yung question ni Joel?
Ano daw po, yung some parrot drones have fish lens mounted for a wider view. Is there a way that the images could be corrected and be able to generate higher accuracy?
Yeah, parrot drones have wide angle or super wide angle cameras. So it depends. This is more for panoramic presentations. Yung mga fish lenses, fish eye views. I think these are not used for survey grade applications. But I think Joel can apply this for the Manila Bay White Sand projects for a panoramic view. Maybe hindi ba maganda yun, Joel, doon sa White Sands natin?
Ayun, sir.
Actually, unmute yourself and
Yes. Yung mga gusto magtanong, you can ask Prof Ping directly if you want, if you have the courage. Oh,
bakit parang ayaw nila ha?
oo nga, parang takot ba kayo? Hindi mo kayo lalamunin. Hindi naman graded recitation to, guys.
Sir, ito po yung tanong ko rin dati sa'yo. So, meron na po daw ba manual ang drone operator na dapat GE lang ang na makaka-operate in all surveying activities? Meron daw siyang supervise, hindi GE ang drone operator, IT siya, pero may permit to operate the drone.
Actually, the manual that was presented or generated for the LMB is for outputs to be submitted for approval by the LMS. Now, as far as operation is concerned, this is a co-op thing. And licenses to operate are beyond the jurisdiction of the manual for issued by the LMB. So even the manual by the LMB does not specify that it should be operated by a GE only, provided the signatory to the output is a GE. This means that the GE validated the accuracy of the output. No matter who made the flight, ganun din naman tayo sa traditional surveys. The instrument man may not be licensed. Even in traditional photogrammetry, the stereo plotting operators may not be licensed. But the outputs, when submitted to the client, have to be signed by a license if needed. But there are outputs not necessarily signed by the GE. So there is no such manual that authorizes only GE to operate the drone.
Okay.
Purposes po, for surveying purposes, dapat GE should...
For surveying purposes, depends even then. If it's not submitted for approval by the LMS or the LRA, or even forwarded to the NAMRIA for comments, anybody can use it. It's a tool anyway. It's a tool. So our concern is the public safety, So the public has to be protected. That's why we need the license. But if the user is not concerned with the accuracy, is not concerned with whether it is accurate or not, then anybody can use this, just like any other tool.
Thank you, sir. Sir, may tanong po ditong isa pa. Meron daw siyang 500 hectares of property na isa-survey and he'll be using DJI Phantom 4 Pro. Ano daw po yung suggested yung flying height so that he would have the best possible image for planning and design?
I think Ariel would be in the best position of Sina Louie for that extensive area. No? I think there are different heights for that. Depends the wind, depends terrain. So maraming factors na i-consider. Yes.
Okay. Sir Volts, are you there? Sir Voltaire Tila?
But we have our previous episodes on do's and drones dun sa first part that maybe Sir Lord Byron ba to can go back to kasi nandun yung parang
determine kung ano yung flying height.
Kasi di ba we are for accurate service na for tightening we are aiming for 1 or 2 centimeters GSP. So yun. And also back to
you guys can...
Yan ba? Yes. May tanong ba regarding sa yung sa flying height?
Yes, sir. 500 hectares daw po yung niya.
Yung kung for planning lang. For
planning and design.
Yeah. Siguro, kaya niya hanggang mga 120 meters. Since naman yung limit natin, di ba? Civilian. 120 meters to 100 to 120 meters. Enough
Property,
na yun.
property survey.
Property survey. Kung
Ayun,
Phantom 4
property.
kasi, ang talaga habol natin talaga doon yun, di ba? Yung 2 cm na GSD eh. So kung sa Phantom 4 Pro, to achieve yung 2 cm, less than 2 cm talaga nasa 60 to 70 meters.
Yan.
Okay.
Okay. Thank you, Boss. Ayan na, si Miss Cruzet Kyocho of NIA. Nag-raise na ng hand. So, can we unmute her, Angela?
Sige po.
Sige, Cruzet.
Yes. Good morning po, Prof. Ping.
Hi, Rosette. Good morning.
Good morning po, sir. Ang question ko, sir, yung sa kanina, yung sa site condition. Kasi knowing na from NIA po kami, syempre pagkagawa po ng dam, hindi pa naman po malinis yung terrain. So, ang concern ko po sa drone survey po ba, with that accuracy, pwede po ba yan sa kahit anong klase ng site condition? Like yung maraming vegetation, rolling yung terrain, is it advisable to use those that method para sa ganun po?
I think if it is highly vegetated, it should be a LiDAR drone, a drone with LiDAR, so that you can map the terrain more accurately. I think that's a technology that's used for terrain covered with vegetation. If you use the camera, it is still possible, but again, the accuracy for such vegetative area may not be as high as with LiDAR. Unfortunately, with LiDAR, you need to invest a little more than using the ordinary camera for the drone. Yes, you can use that. I think for the dam sites, that's for a pre-feasibility or feasibility stage, the drone should be very useful. Yes.
Okay. Thank you, Prof. Ping. Thank you, Ma, for that question. Sir, may last pong tanong dito from Sir Melvin Candelario. Possible daw po ba magkaroon tayo ng ng Mohon carrying drone, high-end drone? Ano po kaya daw yung mga centimeter correction? At ano bang ibang other corrections na pwede nating i-consider or factors to consider when we have that kind of drone?
With the standard drone, I think it's not possible because the Mohon would be heavier than the drone. If you know the test that was successfully handled by the Israeli engineers, at the payload of only 9 kilos. So the Mohon may weigh more than 10 kilos already. So unless you're using an aircraft, but the aircraft cannot fly very low. Our traditional aircraft for mapping flies about 2,000 meters, 2 kilometers up, unlike the drone. So I think it's highly unlikely in the near future.
In the near future. Okay.
In addition to Prof. Ping, may sinabi din si Engineer Joel Marundan, Mohon carrying drones, that would mean that it would be light aero vehicle with a payload of more than 250 kilograms to be able to carry 10 Mohons with a Mohon weighing 25 kilograms. So it would not be economically feasible now than the conventional method. Unless otherwise, Mohons will be designed from lighter materials like aluminum, alloy, or titanium, or lighter markers like brass sticks.
Ayun.
Meron
Okay.
pa si Sir Brian Anyos.
Opo. May si Sir Brian naman, this is in relation to the question kanina about the 500 hectare property survey. According to him, 120 meters yung flying height, 500 hectares Phantom 4 Pro, an average of 20 to 25 minutes per flying, plus sa abuti ng 800 to 900 hectares para maging rectangular or square ang image.
That's for pag-planning, no? For planning.
And last po, if anyone, apart from Prof. Ping, if any of the GPs have tried this, may nakagamit na daw po ba ng context capture processing software? If maganda ba siya gamitin or not? Because I think Ma'am Joanna is planning to purchase for her department.
Ay, hindi
Meron.
yun context capture processing software. First time ko marinig.
Ako rin, first time ko rin marinig yun. Kayo po ba, Prof. Ping?
Yes,
Na,
maybe Voltaire might know about it.
Context.
Sir, ngayon ko lang din narinig po yun.
ayun. Ngayon lang po namin narinig ito. Hindi
That
namin
should be the
masugot.
topic in another webinar.
Baka any of our participants know about this, they may directly declare Ashley Taborada so that they can
Context
share
capture.
this software. Sino nga ba yun? Si Miss Joanna Taganahan Balutaulo. So if anyone about context capture processing software.
Okay. Thank you, ma'am, for that question. Mag-explore din kami about sa processing software na ito. Ngayon din namin na narinig.
Ito po, sir. Pag matuloy daw po ang 3D cadastre, ilang percent po kaya ang success rate nito? Kasi sa 2D po, hindi pa natin maayos-ayos Sa Region 2 daw po ito.
Hindi ba ang reported completion niya 100% na? So, naayos na siguro. Ayun ko, we have to ask the LMB or DNR siguro. They should be more familiar with that. I am not privy to the status of the 3D project now.
Parang they're aiming for 3D cadastre. Pero yun nga, sir, parang baka mag-pilot sila ng area na medyo maayos na yung 2D. So, parang facing din naman po yung
facing, yeah, correct.
Papunta sa 3D cadastre.
Yes.
Okay. Okay, guys, if wala nang questions, I will now end this Q&A part of the webinar. If you have more questions that nag-pop sa inyong head sa later part of the day, you may ask us through our Facebook page, Technology for Property Rights. Also, if friend nyo si Prof. Ping sa Facebook, I think you can ask him.
Prof. Ping, may Facebook ka pala?
Dati meron pero nakalimutan ko yung password ko.
Ayun lang. So guys, I'm going to send the link for the feedback form. So hope you guys will answer it because we're also gonna base your names on this feedback form. May pahabol pong question. Can drones replace terrestrial 3D scanning? Sa tingin niyo po, Prof. From Joel Marundan ulit.
Joel, 3D scanning can be airborne, it can be terrestrial, di ba? And the same accuracy. Yes.
Okay, guys. So if you have wala na kayong questions, please do answer the feedback form. I would also like to take this opportunity to thank our partners. We have FEF and also the Asia Foundation. Also, we would like to thank Prof. P for giving us his time today to share with us his knowledge on, well, we all know he's very knowledgeable in this field, to share his time with us in this webinar, and also my fellow panelists for helping me out. This webinar will also be uploaded in our Facebook page and the YouTube channel of the Foundation for Economic Freedom, just in case you want to go back to some of Prof. Pink's slides. And lastly, we will be providing certificates within the next week and also the presentation of Prof. Pink. So it's very critical, guys, that you answer our feedback form. If you have if you have a trouble with the link that I've shared, you can also use this one.
Angela, like them, we also would like everyone to please like our YouTube channel. Our previous episodes of cut episodes of our do's and drones. Earlier previous episodes are posted on our YouTube channel, Foundation for Economic Freedom. So please do like and subscribe and share. Thank you.
Okay, guys, thank you for joining us and hope we see you again in our next webinar. So please do watch out for our posts and announcements.